students. So in the last video we have completed with the determinant topic. Okay, so the next topic I am going to start, that is relation and functions. Okay, so this topic already you have studied in the first year. Okay, so in the first year, what are the basic concepts, okay, you have studied. Okay, and what are those concepts you have studied in the first year? What are the concepts are? First one is Cartesian product, domain and range, and functions. Okay, so this is basic one. Okay, the first concept, Cartesian product. Okay, so suppose we are having the two sets, that is A and B. Suppose we have the two sets A and B. The Cartesian product of this A and B is denoted by, that is A cross B. Okay, so the Cartesian product of this A and B is represented by, that is A cross B. Okay, then how to calculate the cross product of the two sets? That is what, suppose I am having A is equals to 1, 2 and B is equals to AB. Okay, then how to take the Cartesian product of this? That is A cross B is equals to. Okay, now so from the first set, take the first element and make the pairing with the other set elements. Okay, so that is what, 1A, that is your first order pair. Next 1B, that is your second order pair. Next, now take second element and you make the pairing, that is 2A and 2B. So this is your Cartesian product of the sets A and B. A and B. Okay, so this you learned in the first year. Next concept is domain and range. Domain and range. Now how to take domain and range in the given relation? I will say in the given relation. So before this domain and range, I will define one more definition, that is relation. That is what? Relation. So what is the definition of relation? Relation is always the subset of the Cartesian product. Relation is always the subset of Cartesian product. Means what? Suppose if I denote the relation by R, then always it is a subset of the given Cartesian product. Suppose if there are two sets A cross B, then that relation will be the subset of that Cartesian product. Okay, and that relation or that definition or that expression is called as a relation. Okay, so simply we say that relation is the subset of Cartesian product. Okay, now come to the point of a domain and range. Okay, once you have the relation, any relation is given. Okay, and from that relation, how to take the domain and range? Now, as we know that R is a subset of Cartesian product. Okay, so therefore it becomes one of the relation, right? Now, so in this, how to take the domain and range? Suppose if you are having the ordered pairs in the relation, then every first element in the relation, or can say every first element present in the ordered pair is called as domain. Now what is the domain here? Now 1 is repeated twice, so that repeated number you have to take only once. Okay, so therefore domain is 1 and 2. Okay, next, what about range then? Range means what? Every second element present in the ordered pair. Every second element present in the ordered pair. So second element is what here? A and B. A and B. If it is repeated, you have to take it only once. Okay, so this is your range. Okay, this is also learned in the first year only. And the next concept is functions. Okay, now function means what? Function means what? Suppose you have any relation. In that relation you are having domain and range. Okay, then when we call the given relation is a function, suppose every element of domain have unique image, or can say only one image in the range, or can say codomain. Okay, see this range. For this range also we call as a codomain. Also we call as what? Codomain. Okay, so I'll define the function. So function means what I said, theoretical definition. In the relation, okay, suppose each element of domain have only one image in the codomain, then it is called as a function. And see, always function we represent in one of the mapping, okay. So f is mapping from A to B. F is a mapping from A to B. Means while reading, how we read this? F is a mapping from A to B, okay. Or simply you can say that f is from A to B. In this, A is domain, B is codomain. B is codomain, also called as a range. Also called as what? Range. Okay. Now see, I will define the same function definition with the help of arrow diagram. With the help of arrow diagram. Okay. So this is your set A. This is set B, and its mapping is F. Its mapping is F. Means function F is from A to B. Suppose I am having A set is 1, 2, 3, and B set is A, B, C. Okay. Now one image is A, two images B, three images C. Now if you observe here, this is your domain, this is your codomain. Okay. Now see, one image is A. Here one is having only one image. That is what? A. Two images B, three images C. Now whatever this arrow diagram is there, this represents f is a function. F is a function. Suppose now if I make one again is having one more image, that is B. Now this one is having two images, that is A as well as B. Now this f is not a function. This f is not a function. So to given relation is to become a function, then it must have satisfy one condition, that is what? Every element of domain have unique or only one image in the codomain. Okay, that is called as a function. And also we have seen some types of the functions in the first year, that is polynomial function. Standards are like modulus function, greatest integer function, signal function, rational functions. Okay, these are the types we have studied in the first year. So this is all about first year knowledge. Now we'll come to the part of second year. Okay, in the second year what we have, okay, some more extra part of the first year. So in the second year we are going to learn the types of relation and some two standard types of functions. Okay, now at the beginning I will go with the first part, that is what? Relation. Okay, we'll see that. So as I have defined the definition of relation, that is what? Relation is the subset of Cartesian product. Relation is the subset of Cartesian product. Okay, so again I am not going to define that definition. Then what are the types of the relation? We are going to start with the types of relation. Okay, so in this types of relation, first type is empty relation. First type is what? Empty relation. Now what is meant by empty relation? Suppose we have one set. Suppose set is A. Suppose we have one set, that set is what? A. Now the elements present in set A, if they are not related with any element of set A. Okay, means the elements they are not related. The present element in the set A, then we can say that it is a empty relation. Okay, means there is no relation will be found in that set, and that relation is called as what? Empty relation. For example I will take, suppose set A is what? The set of all ordered pair AB such that, this is a relation. Okay, see now I will take the set A is what? That is all students of boys school. All students of boys school, and I define the relation is the set of all ordered pair AB such that A is sister of B. A is a sister of B. Okay. Now if you observe here, which set we are having? All the students of boys school. Okay. So school is which school? It is a boys school. But what is the relation they have given? A is a sister of B. Okay. Then do we find any sister relation in the boys school? Not possible. So therefore, this relation becomes what? Empty relation. This relation becomes what? Empty relation. Okay. Now second one. Universal relation. Universal relation. I think this universal word itself define what is meant by that universal relation. Okay. Now universal relation means what? Every element of set A is related with all elements of that same set. Means every element is related to itself. Every element is related to itself, or you can say every element is related to all the elements present in the given set. That set is called as what? Universal relation. Universal relation. Even for this also I will take the example. I will take the set A, same set, but just will define different relation. The set of all ordered pair AB such that, okay, such that the difference of heights of A and B is less than 3 meters. Is less than 3 meters. Again I am having the set is it is a student of boys school only. Okay, but how the relation is the set of all ordered pair AB such that the difference of the heights of that A and B student is less than 3 meters. Is less than 3 meters. Okay, means in the suppose for example in the class 60 students are there, and you wanted to check the two students difference of the height should be what? Less than 3 meters. Then for that what you have to do it? You are going to take one student. Okay, that one student you have to relate with all. Means what? That one student height you are going to compare with all the students. Then only you can able to find the difference between the two students of height is less than 3 meters. Okay, if you select any randomly, then it is not possible. Okay, if I select one student here and one student here, which is not possible. Okay, so therefore which is the easiest method? One student you have to take, and that one student you have to compare with all. Means what? Here that one student is having a relation with all the students. Therefore that one student is related with all the students. That means all the students in the sense what? It is a universal relation. It is universal relation. Okay. So this is second type. Now next, third type. See, next third, fourth and fifth type is very important as per the examination point of view, because on that maximum questions will be asked. Okay. So third is reflexive relation. Reflexive relation. So here I will give you the simple definition. Okay, you just remember the definition. Reflexive relation means what? That is, the ordered pair AA belongs to R for all that element A belongs to the set A. Belongs to the set A. So this A element I have chosen from the set A. But when that relation is called as a reflexive, when this condition satisfies, that is what? The ordered pair AA belongs to R. Means this ordered pair should be present in R. For example, if I having this A is 1, then it becomes what? 1, 1. So that 1, 1 ordered pair must be present in R. If it is present in R, then you can say that that relation is reflexive. Okay. Then fourth one. Symmetric relation. Next one is what? Symmetric relation. A symmetric relation is what? The ordered pair AB belongs to R. The ordered pair AB belongs to R. Then that must implies the ordered pair BA is also belongs to R. For all that A and B, again we have chosen from the set A. Let A and B are chosen from the set A. Now, when this relation is symmetric, see, suppose this AB belongs to R, means what? You must have one ordered pair which is present in R. If it is present in R, then its reverse ordered pair should also present in R. Then only that relation is symmetric. Now, for example, if I take here 1 and 2, 1 and 2 present in R, okay, and that implies what? 2, 1 also present in R, also present in R. Then only this relation is called as symmetric. Okay, suppose if having 1, 2 belongs to R, but this 2, 1 is not present in R, then we can say that it is not symmetric. It is not symmetric. Okay, third one, sorry, last one, that is sixth one. Transitive relation. Transitive relation. Okay. Now this transitive relation, how it is defined? See now. If AB belongs to R and BC belongs to R, that implies AC belongs to R. For all A, B, C should be present in set A. Should be present in set A. So to define reflexive, we require a single element. To define symmetric relation, we require two elements A and B. But to define transitive relation, we require three elements A, B, and C. But see, when you call this relation as a transitive relation, again for that you must have this two ordered pairs in the relation first. That is, AB belongs to R and BC belongs to R. Okay. See, these two ordered pairs you have to choose in such a way that first ordered pair second element and second ordered pair first element must be always same. Suppose if you have taken 1 and 2, then here you should take 2 and any other number, but here it should be 2. Okay. Suppose the two ordered pairs are present in R, then that implies what? AC belongs to R. Means what? This first element and this last element belongs to R. If it is belongs to R, then we can say that given relation is transitive. Suppose these two are present in R, but this is does not belongs to R, then it is called as R is not a transitive. R means relation. So relation is not a transitive. Okay. Now in this transitivity, I will explain one more concept. Okay. What that concept is? Suppose now you are having AB belongs to R, but you don't have the ordered pair, which is BC belongs to R. Means here B is there, so that type of element ordered pair you don't have. Okay, in that case we can say that relation is not a transitive. Okay, it is a transitive only. It is transitive only. Why? Because you don't have any proof to say that it is not transitive. When it is clearly not transitive, when these both are present in R, but this third ordered pair, if it is not present in R, in that case you can say that R is not transitive. Okay, but suppose AB is present in R, but this ordered pair you don't have. This ordered pair you don't have. In that case, we have to conclude R is transitive only. Okay, so for that I will give you a simple example. Okay, what is that example is? Suppose from my home, in my home, one thief has come and he's stolen my some amount. Okay, some amount is stolen by the thief. Okay, I have seen that. I have seen while that stolen the amount, that time I have seen him. Okay, but when I complained regarding that thief, then that case has been registered in the court. Okay, then in front of the judge, we both are standing in front of each other. Okay, I am standing at one corner and in front of that thief is also standing. Okay, then judge has asked me what you have the proof to to say that he is a thief. Okay. So one thing is clear here. I have seen that he is a thief. Okay. But judge is asking for the proof to say that he is a thief. Okay. Just by on my statement, judge will not decide that or judge will not punish that person. Okay. Because he needed a the proof. Okay. So if I give the proof that, suppose if I taken the picture of that while storing some amount, then I may have the proof to show to the judge. Okay. But I don't have any proof now. Just I am saying by the mouth, just by giving the statement. So judge will not give the punishment to that. Okay. Suppose if I have the proof, then definitely the judge will punish that person. Okay. So here also the same. To say that it is not transitive, you must have both the ordered pairs. Suppose among this one ordered pair is absent, then also you have to conclude R is transitive. Okay. Now these are the most important three relations you have to remember. Okay. So you just go through it. You had these definitions. Okay. So based on the same definitions, we will solve the examples in the next class. Okay. Thank you.